Now we are in section 5.4, okay? Well, it is almost the end of semester already, okay? But keep that in mind. The good news is, like, this is not something new. That's exactly same thing what it learned before, okay? We would like talk about antiderivative, okay? But with different name, which is indefinite integral, okay? So basically, like whenever you have indefinite integral, this is indefinite integral form, which means there's no interval, right? Then we just simply ask you to find antiderivative, okay? Does it make sense? So it's not something new, but that's exactly the same thing with antiderivative, okay? One more thing that I want to mention is here, okay? So when you find definite integral, that was the net area which is enclosed by curve and x-axis between A to B. So which means it is number, right? It is number, okay? But your indefinite integral, it is just antiderivative, right? So which means it is still function, okay? So again, definite integral is number, but indefinite integral is a function, okay? That's really important understanding for whole this chapter, okay? Wow, we have 15 items in this table, right? It's too much, right? But let me tell you like good news, okay? You don't have to worry about that, okay? Because these are exactly same thing with the like, you know, items in the table of the derivative, okay? Same thing, but like it is just opposite operation, okay? So you can like get hold this thing easily, okay? And another good news is like integral part, and you can easily double check your answer, right? So like if you have like any antiderivative problem or indefinite integral problem, then like once you get the answer, just take the derivative that it must be in the problem. This is the way to double check your answer is correct or not, okay? So now let me give you a problem for the practice, okay? Here we go. We have a couple of problems, okay? So I strongly recommend please practice as much as possible, okay? Try to solve all the web assignment problem and lecture note and try to find some more problem from your textbook. I strongly recommend, okay? So practice is best way like to be good at like this chart, okay? Here we go. So let's work in here, okay? So integral like this one. The question about indefinite integral, right? But as I told you, it is same thing with the antiderivative problem, okay? So we can answer this one directly, okay? Here we go. So x to 6 is 1 over 7 x to 7, okay? I'm talking about power, right? And second one, minus 2, 1 over 6, 6, right? And then minus 1/4, 4 and constant, okay? And don't forget constant c, integral to constant, okay? Then let me simplify. It is equal to 1/7 x7 minus 1/3, 6 minus 1/4 x to the 4, 2 over 7. Wait a minute, I miss x here, right? And c, that's it, right? And what about second one? Same thing, we're gonna use the power rule, right? And to do so, let me try to write this one as the power function form. It is equal to integral x to the 5 over 4 dx. That's it, right? Then what is antiderivative or indefinite integral? It is equal to 1 over your power plus 1. That's exactly what I did in the previous problem. X to the 5 over 4 plus 1. And don't forget constant c, right? So that is equal to 1 over, just simplify, okay? It is 9 over 4 x to the 9 over 4 plus c, right? Which is equal to 4/9. It is a compound fraction, right? X to the 9 over 4 plus c. That's it. I wrote 9 here. Okay. Nine over 4. That's what I wrote, okay? And then what about next one? Okay? So here we go. Same thing, okay? By the power rule, it is 2 times 1/4 x to the 4, and then minus 6 times 1/2 x squared. And then what the next one? It's not a power rule, but we are familiar with this one, with when you do not have like 3 on your top, right? Which is 1 over x squared plus 1. That is arc tangent, right? So it is 3 arc tangent of x, and don't forget constant c. That's it. Oh, not that's it. So we have to simplify a little bit, okay? It is equal to 1/2 x to the 4 minus 3 x squared plus 3 arc tangent x plus c. Now, that's it.